Hello, thank you for visiting Deloach Education on YouTube. I'm Gary Deloach, and in today's video, we are going to be looking at finding the volume of compound solids. Now, before we jump into finding the volume of compound solids, I want to make sure that we review finding the volume of a normal right rectangular prism. So, in this shot right here, there's a rectangular prism that has a length of 7, a height of 9, and a width of 3. The two volume formulas that I've discussed in my classroom are one being length times width times height, and the second one being base area times height. So what I'm going to do right now is just make a list of the information that I can gather from the image that I'm shown. So the length is, let me get my pen set. The length is 7 yards. The width is 3 yards, and the height is, and that looks like a nail. Let me erase that so no one is confused. And the height is 9 yards. So we're going to use that formula V equals L times W times 8. So first thing we're going to do is 7 times 3 to find the base area, which is 21. Then we're going to take the base area and multiply that by 9. And 9 times 21 is 189. That's pretty simple. The volume of this rectangular prism is 189 cubic yards. And you can write that as yards with an exponent of 3, or you can actually write out the words cubic yards. Alrighty, so now let's jump into finding the volume of a compound solid. The first thing you notice when you look at this is the fact that it actually looks like two rectangular prisms that are combined. So that's how we're going to visualize it, and we're actually going to separate it into two rectangular prisms, and we're going to find the volume of both. There's really no specific rule that says that you have to split it vertically or you have to split it horizontally. I typically just split it the way that looks best in my opinion. We could very well have split this going across this way, so horizontally. I'm going to label my rectangular prisms. The one on the left, we're going to call it A, and the one on the right, we're going to call B. And on both sides, I'm going to make a list of the information that I can gather from the figure itself, and then find the volume of rectangular prism A, then use that information also for B to find its volume. All right, so here we go. Over here, we're going to list the information for A. So volume of A, we know we're going to need a length, we're going to need a width, and we're going to need the height. My pen just won't allow me to write that very well. Do the same thing over here. I'm going to make a list. So volume, B, length, width, and height. So let's find those dimensions. The first thing we're going to tackle is the length. We're going to look at the length. We're going to look for the length for both figures. And the reason why I like to do this together is so that students can see the side-by-side comparisons. So how I'm looking at the information and choosing the length for A, and how that also relates to the length for B. So rectangular prism A. Oh, one more thing. Just to point out, when I'm looking for length, I'm looking for the left to right distance. When I'm looking for width, I'm looking for the front to back. And when I'm looking for height, I'm looking for the top to bottom distance. Now, it does not matter. I mean, when it's all said and done, it doesn't really matter the order in which you multiply them. However, what you need to be careful of is making sure that you're using corresponding terms to describe the length for A and the length for B and the width for A and the width for B and the height of A and the height for B. Because I don't want to call the up and down the length for A and then call the left to right the length for B. Okay? So, again, length is left to right, width is front to back, and height is top to bottom. So, the left to right for A is going to be this part right here. But you'll notice down here at the bottom there is no known value. So what we have to do is look for other information in the figure or that's labeled on the figure to help us determine what this length is. So up here at the top, we see that the length of the entire solid is 6. Down here below B, we see that the length is 3. So if B is 3 yards, the whole thing is 6 yards. 6 minus 3 would tell me that the length of A is also going to be 3 yards. Alright, so now let's focus on the width. Now again, that width is the front to back, so of A, that one's pretty easy because it's labeled. The width is 2 yards for A. And then B, it's easy for us again because it actually gives us 3 as the width for that one. Alright, now let's focus on the heights. So we're talking about the up to down. So the height of A is 5 yards. And then up to down over here is also 5 yards. And I came to that conclusion because you'll notice that there is no difference in height when you look at this from the front. So if A is 5, B is also going to be 5. Alright, now we have a length, a width, and a height for figure A, or rectangular prism A. And we have a length, a width, and a height for rectangular prism B. So I'm going to apply those volume formulas, and remember, it's V equals L times W times H. So 3 times 2 is 6. 6 times 5 gives me a volume of 30 cubic yards. Over on this side, and I should probably change that color so you can see it a little bit better, to just make sure there is no confusion. Make it purple. Alright, so for volume B, we do 3 times 3, which is 9. 9 times 5 gives us a volume of 45 cubic yards. So the volume of A is 30, the volume of B is 45. So now that we have the volume of both of those rectangular prisms, we're just going to find the sum of the two. So we're going to take 30 plus 45, and the volume of this rectangular prism is 75 cubic, or not this rectangular prism, the volume of the whole compound solid is going to be 35. so let's try one more before I end this live session and before I wrap up the video. So on this one, I am going to divide it horizontally. Just for my friends who prefer to do it horizontally. Kind of cater to your preferences on this one. So remember, last time we labeled them. I'm going to call this one right here A. I'm going to call this one B. And over here, we're going to list the dimensions for A. So volume A. And then over here, we're going to list the dimensions for B. And we need a length, a width, and a height. Length, a width, and the height. So let's go ahead and find those dimensions. So again, our length is going to be left to right. So since we're looking at it this way, we know that A is going to have a length of 5 inches. B, it gives us the length back here. So for B, our length is 1 inch. Now let's focus on the width. So the width is going to be our front to back. And that is 10. So volume, for A, the width is 10. And for B, the width is going to be 10. Because you'll notice these sides correspond. Alright, and finally we need to find our height. And for A, we got to do a bit of thinking on here. So let's look at B. We're given the height of B back here, which is 1. So if B is 1 inch, the height of the whole thing is 2 inches. That must mean that difference between the two will be 1. So the difference, meaning the difference in the total height and the actual height of B. So the total height of the whole thing and the actual height of B. So both of them are going to have a height of 1. Now what I need to do is find out we need to find out what the volume is. So again, we're applying that volume formula, which is length times width times height. So 5 times 10 is 50. 50 times 1 is 50. So we get a volume of A, which is 50 cubic inches. And for B, it's 1 times 10, which is 10. 10 times 1, which again is 10. So we get a volume of 10 cubic inches. Now we're going to add the volume of A to the volume of B. And 50 plus 10 gives us a total of 60 cubic inches. So the whole thing is 60 cubic inches. As usual, if you have any questions or comments related to these videos here, if you're a student of mine, of course, you can talk to me in class. If you are not a student of mine, feel free to email me at deloacheducation@gmail.com. That is DeloachEducation@gmail.com. Thank you for tuning in to this video. I hope it can be used to help you understand how to find the volume of a compound figure. Thank you.